In the previous session of MATLAB fundamentals, we were looking at a variety of matrix operations. Basically, we have been discussing about the permutation of a matrix, how to perform the permutation in terms of changing the rows into columns, columns into the page numbers, and page numbers back into rows, etc. We have seen, right? Okay, so now in today's session we will begin with, okay, so we can start with the what is called as a squeezing operation. Okay, so this is squeeze. Right. So let us say that we are working with a multi-dimensional array, and we might encounter one that has a unnecessary dimension. Correct? So there is a possibility that the multi-dimensional array which we are handling right now may have one of the dimension which is not at all required. Okay, so MATLAB supports the detection of such a dimension automatically, and it can squeeze that dimension. So that's why we use this particular command called squeeze. Let's see how this works first, then we'll do the MATLAB programming as well. All right, so the elimination of this is unwanted dimension of an array. Specifically, we are dealing with multi-dimensions. In an multi-dimensional array, what happens is it can detect the unwanted dimension, and it can actually bring that back into the normal state. In the sense, it can actually eliminate such dimension. Okay, so this is what is the squeeze function is going to perform. Right. So let us see how this is going to work. All right. So let's first go to the MATLAB screen, and in the MATLAB screen, let us first create a array. Okay, by using what is called as a ripmat function. So let me create an array. Say A is equal to, I use a function called repmat. It is just used to repeat the matrix, right? I just use a single value to be repeated. I'll say this is 5. I want to repeat 5 many times. So how many times you want to repeat, you can specify that using the square bracket, right? I will say I want 2 rows. Okay, I want 3 columns. All right, and say I want 1 page, and now you see I'm going to make this as a 4th dimension. See, I will say 4 such what you call books. This is like a book. So the 3rd dimension will be a page. 4th dimension says how many such books you want, right? Now you say every book has only 1 page. The 3rd one is just 1, indicates that that particular dimension has no sense now, right? It's something like you are saying that I have 4 books, each book is of just 1 page. Doesn't make sense, right? It's like all the 4 single pages in 4 different books can be clubbed together to form a single book. So there I'm trying to make you understand that what do you mean by a dimension which is unwanted, right? That has no significance. So in this case, you can see that this particular third dimension has no significance because it is only one, right? So I repeat what I said. So you are trying to create 2 rows, 3 columns in a particular page. Okay, how many such pages? It's just one page. How many such books you are creating? 4 such books you are creating. So this is 2, 3, 1, 4. That's the dimension we are entering here. And I'll just close this. Now you see it actually creates a matrix A of our specific size. So ultimately you can see that this can actually be created simply by specifying rip mat 5, 2, 3, 4. That also creates the same thing, right? 2 into 3, 4 such copies, right? So that means the one dimension which I mentioned here has no meaning. So that particular dimension can be squeezed directly by using the squeeze command. Okay, so I'll just show you that how to find out the dimension. So what I'll create the size variable. Say I'll create a size variable sz of a. Sz size of this matrix A is equal to, I can write the size of A. I just want to make sure that it is still 4 in dimension. I have not reduced, but though the display says that it looks like a 3-dimensional case. So now you see here, it's the size is 2 rows, 3 columns, z direction is 1, 4 such copies. It is still 4-dimensional signal. Okay, 4-dimensional matrix or 4-dimensional function. Okay, now my objective is how do I bring it back to the 3-dimensional array format, right, by using a squeeze function, right? It's obvious that it can be reduced. All right, so let's do that. So also I'll show you another function now. So that function basically is used to find out the number of dimensions of any function. So it's actually, so I'll call okay, I'll assign it to num_dim, number of dimensions, is equal to, the function is called as ndims. So ndims, indicating the number of dimensions of whichever function you want to find. So my function now is a, right? I'll just enter a. So you see it says that this particular function has 4 dimensions, right? So you learned 2 more things now. So one is the creation of 4-dimensional signal, 4-dimensional function, and out of which purposefully we created one of the dimensions, we made it of no significance, and then now we are using a functions to ndims to find out the number of dimensions in an array. And now we'll ultimately learn how to reduce that dimension. Okay, so what I do, I will okay, and n is equal to 4. Okay, now I'll create a matrix B. So matrix B is obtained by simply performing the squeeze operation, squeeze. Okay, this is squeeze of A. All right, so now again the display looks very similar, so I don't want to display this. I'll just skip that part by entering a semicolon. I don't want to see B, because B and this A will look very similar to you, right? Because you are suppressing the one of the coordinates. So even we can see that, doesn't matter. So just enter. So you just see it's like this. So the display says 5 5 5 5 5, all 5s are repeated. But now how do you find out? You go for size. Go to the size of B now. So you see it is 2 3 4. Right, so as expected, the squeeze function identified that your 3rd dimension is of no use. So instead of creating 4 different books of 1 page each in each one of them, simply club all the 4 pages, make it a single book. So the 3rd dimension was not of any use for us in that case. So it actually squeezed that dimension and brought the 4th dimension into the place of the 3rd dimension. So that's the use of squeeze. So many times when we collect the actual signals, right, from some sensors, multi-dimensional signals you may collect, maybe it is from radar or maybe from satellites or many data, right? You get this kind of situations. You don't know, you have maybe 10-dimensional signals possible, right? Out of which few of the dimensions are of no use, right? So you can simply call the squeeze function at the beginning to compress that and eliminate these unwanted dimensions. Okay, so that's our basic idea over here. It's very useful function in MATLAB. Also, so after we use the size, you can actually find the n dimes as well, n dims of this B matrix. So you see it says it is 3 now. Earlier, if you remember, this was 4. Okay, so that was 4. Now, by obvious reasons, we have only 3. Alright. So, next we will go to after squeeze function. Now, let's move further. This is about the creation of what is called as the next topic is to create the floating point data. This is very important by obvious reasons that you may require varieties of numbers to be presented and handled by any software. Okay, this is because we have varieties of number representation like single precision, double precision, etc. Okay, so the number of bits that have been used by a computer to store the data varies from architecture to architecture. For example, when we install our operating system onto our newly purchased laptop, maybe we look for what is the architecture. Is it 32-bit, 64-bit? This is true even for mobiles or handheld devices and so on. Right? Whenever you install, you will look for what is the architecture. According to that, you install the software, because right, the precision of the numbers that get stored in 64 bits or a larger memory devices, the precision is more. I get more accurate data. Okay, this is the only reason. So we prefer that. So according to the variety of representation possible in any architecture, we might have to vary our the way in which you display the data as well. Okay, so for that reason, now we use the double precision to store a value specifically greater than a number, right? Because if you have, say, 10 bit space, let's assume I have 10 bits space. So when you have 10 bits of space, you can write what is the largest number you can store over there, like all 1111 if it is in binary. Okay, or I have 10 digits space. So whenever I have 10 digit space, what's the maximum number you can store over there? All 9s. Correct? So 10 bits, 10 digit space I have, maximum number you can store is 99999, all 10 digits being 9. More than that you cannot store. Correct? So what is the idea to store a bigger number than that? That is called as a double precision number. So I will show you the conversion between single and double conversion. How to convert single and double, vice versa in MATLAB. This is also very useful. We need this. Okay, so basically what MATLAB performs is it uses, I'll simply write, see, you can use the double precision to store values greater than, say, this number 3.4. I will write e as exponent. This is 10 to the power 38, right? Or it can be the other side, or less than. Even the negative side you have a value like minus 3.4 e 38. So e is actually exponent that denotes 10 to the power numbers. Okay, 10 to the power 38. If you want to store greater than that or lesser than the minus 3.4 e 10 to the 38, you can go for a double precision representation in what you call in MATLAB. Alright, so I directly jump into the MATLAB to show you how this process is going to work. Okay, right. So now let's clear and allow the CLC first. Now first let me create a number, right? Let me create a larger number. For example, I'll create say y is equal to you see 64-bit representation is denoted by int. It is an integer of 64, right? This is a function, right, which we use to create that. Now you can actually enter the number. All right, so just look, I'll enter a very big number, maybe 5 8 9 3 2 4 0 7 7 5 7 4. Let me, okay, let's say this is a big number. All right, so y is created. It's in the int64 format. Now you see, if I want to convert this into a double precision number, which is actually the e to the number which I entered in that format, it comes in the double format. Now we can convert. So x is equal to, simply create double of say y. See, it got converted. It's minus 5 point something e minus 11, 10 to the power 11. So 11 digits are actually being represented over there. So this is how you convert a 64-bit integer into a double. Okay, importantly. So conversion of an integer into double. Now the vice versa should be possible. Okay, first what I do, I basically create the double precision number. Now you can convert this double into single. Okay, so if you check x over here, it says that, okay, I can actually check that whose x says it is double. It means you are storing using 8 bytes. So how many bytes are required to store this particular number? It is 8 bytes. Okay, now let's do the reverse. We create an integer and we convert that integer into single and see how many bits are required to store that. So that's how you can actually reduce the memory size allocated for storing a variable. So let us say I have 10,000 variables to be created. If you create each variable in the double format, right, 8 into 10,000, so 80,000 locations are required. Whereas if you use the single format, and you will definitely see that you are going to need you are going to allocate lesser space than a double for single. So what I do, I still create the same y once again. Y is equal to integer of int64 of this. This is what I'm creating. And now I do x is equal to, instead of double, use a single. Okay, x is equal to single. You see the representation still looks same, but go to whose x, right? So you see you are storing only using a single precision. That's only 4 bytes are required. Okay, so see the difference. The number is still same, number whose value is also same. You are not going to make any truncation or any approximation, no, but you are allocating lesser space, right? Only 4 bytes are required to store a single data, whereas 8 bytes are required to store a double data. So when your data is smaller, you can use a single type just to save the space when you have many variables to be created of the similar type. So this is the use of conversion between single and double as and when required in MATLAB. Okay, right, then let's move further. Now let's see the representation of what is called as infinity in MATLAB. So let's see how the infinity is being represented, because definitely it's a computational tool and mathematical tool and a scientific tool. So MATLAB, when I'm using it for scientific purposes such as engineering designs, R&D purpose, etc., definitely somewhere you get the term infinity. Correct? So there has to be a facility to represent that infinity in MATLAB. So we are going to look at that now. So this is the concept of infinity. So we already have seen one aspect of MATLAB, that it can use the NAN format, not a number is supported. Again we'll see soon about that. Okay, so now first let's look at the infinity. So infinity for MATLAB, it is INF. You want to create a variable with value infinity? Yes, MATLAB supports. You can assign A is equal to INF, means A becomes infinity. So you see, you can create a variable with value infinity, you can use it in MATLAB, right? So by default, MATLAB understands what are the possibilities of generating an infinity. So we know that infinity can be generated under several cases. For example, when I say I am going to divide by 0, so the result is infinity, right? Or in few of the cases, even the overflow will result in infinity. Okay, so all these are the reasons to create infinity, which automatically the result is automatically assigned as infinity by MATLAB. That's the obvious case. In addition to that, as we know now, we can actually assign something. Okay, so let us see. MATLAB uses that infinity, and according to the IEEE arithmetic standards, IEEE standard is there, which actually creates these rules required for different notations in mathematics. All right, so now you see, now I'll show you that I can check whether an answer is infinity or not by using a function called ISINF. So just see here, this is ISINF is a function. This is a function to verify whether a value is infinity or not. We can check that by using this particular command in MATLAB called ISINF. Okay, let's check the same thing. Let's check whether this works in MATLAB and how to use it. Alright, first let me show you the various ways of various example statements that return infinity as an answer. Okay, just remember in our regular mathematics, or whenever I try to plot an x-axis, y-axis, the values do exist right from minus infinity till plus infinity. Correct? So the obvious question now is that will MATLAB detect minus and plus infinity, or it's just infinity? Okay, so I'll answer you that with this example. Just look at this. So first one is, I want to create x is equal to simply 1 divided by 0. So see, x is equal to infinity. Obviously both are positive numbers, so we are expecting positive infinity over there. Okay, then let me go for another way of creation of infinity. Infinity is a concept of large numbers, correct? So when I say large number, I can still do that. X is equal to 1 e for 10 to the power, so 1000. So you see, this is actually very huge. 10 to the power 1000. The e represents 10. Okay, so you see, it is infinity. 10 to the power 1000 is too huge for the representation in our computer. Computer architecture is not supporting the storage of this number as it is, even if it is double precision. So 64 bits architecture, what we are following now, right? It's not possible for that architecture to store this number as it is. So it's too huge, right? So that's why MATLAB detects that particular number as infinity. Too huge. All right, so let's go to the next example. Say maybe another one, x is equal to, even if we enter exponential e to the power, this is also huge number, okay, e to the power 1000. So see, this is infinity. Again, the same reason, 64-bit architectures, using them we are not able to store this over here. Okay, then let's go to the next example. I want to show you, okay, let's try to create a negative one. I know that log 0 does not exist. Log of 0, anyway, log of 0 point something is negative, correct? So log of 0.5, if you enter, your answer is negative. So I further reduce the number, saying that I want to find the log of 0, doesn't exist. It's ideally speaking, minus infinity is the answer. So just check, see, answer is minus infinity. So the question which I asked earlier was, will MATLAB be able to detect positive and negative infinities? So the answer now is yes, it can. Okay, it will by default differentiate between the positive large numbers and negative large numbers, which are out of scope of storing it in the current architecture of your computer, right? It will automatically detect that. So this is how we detect whether, this is how we generate. MATLAB automatically generates whenever undefined terms comes, and it will assign it to be infinite. Okay, next, we just have mentioned that there is a function that is called IESINF to find that whether a particular value is infinity or not. Okay, so let us just check that now. So I will write, say, x is equal to log 0 I just entered, so I'll simply write IESINF. I know that this x is infinity, I'll just write that. So whether it is positive infinity or negative infinity doesn't matter. If it is infinity, it will say yes. It's a logical function. Just see, answer is logical 1, saying that yes. So my question was, is infinity, right? X is infinite or not? So the answer is yes. Okay, that's right. So using this IESINF function, I can check that whenever some variable that gets created inside our MATLAB program, right, I might have to deviate depending upon it, is it infinity or not. You can use an if condition. If this is equal to infinity, is inf of this equal to 1, do something else, do something else. So we have that branching coming up at later stage when we look at the loops, right? So obviously this is a very handy function when it comes to MATLAB. All right, now let's move further. The next topic that we are going to discuss is the concept of not a number. So infinity is what we have seen just now. So next concept is the NaN. NaN is not a number. So not a number, basically in maths it is NaN, right? So what falls under not a number? So if you remember the concepts in mathematics, it says that if you have a numerical value that is not real, sorry, I'll be right, it's not real at first, or so when we say it is not real, there is a situation that it might be complex, correct? Whenever it is not real, you can say that it can be complex, right? So there are some situations where the numbers are not real or not complex. So those numbers which are not real and not complex, they are not following under any of these categories, right? We will call a special category for them, and we call it as a not a number, right? Where you find these, right? Again, these are very common formats that are being represented in scientific community whenever you read some signals from sensors. Let's assume I read the numbers from the temperature data of the day using a temperature sensor. sensor gives you some values, analog values, you convert that into digital and you put it over the computer to save it, right? But under such conditions, maybe you require a specific range of voltage to be represented for the temperature data, but whenever it exceeds them or whenever it comes lesser than the required, so the computer cannot store that as a temperature value. It simply puts up not a number over there, indicating that so whatever is represented over there, it is not a number of required data type. Okay, this is just an example. Now we will see how do you create, right? So the general example when you do when you get a not a number in mathematics is 0 by 0. So 1 by 0 is infinity, right? Anything by 0 is infinity, but 0 by 0 is undefined. It's not infinity. Okay, 0 by 0 is undefined, so your result is not a number. Okay, so again you can we can even create not a numbers whenever required by simply say y is equal to 0 by 0. It automatically puts not a number over there. It assigns that to the variable which you want to assign. This is the first thing. And let's say you can actually check whether a number is NaN or not. So that can be done by ISNAN. This is a function that can be used to test for NaN. Okay, you can check for NaNs. All right. Okay. Now let's move further, and let's try to write the MATLAB command to check that. Okay. All right. Now first let's see how to create a NaN first. So the NaN can be easily created by using this, that is 0 by 0. See, x becomes NaN, right, by default. Now I'll use ISNAN function. So it says yes, it's logical 1, indicating that the x variable which we have created is not a number. Right, and again in MATLAB you can actually create an array of not a numbers. That's also allowed, right? And anyway, I don't think that is useful for our purposes, but maybe there are some situations which end up in such arrays as well. Okay, but anyway, so that's the reason why right now I'm not creating such arrays, but definitely MATLAB supports. Right, if you want, you can do that. Even the infinite numbers can be put up over an array, right? So x is equal to, you can create an array of infinity, 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 right? Definitely, right? That's also allowed. Okay, then let's move further. Now let us try to club the integer type. Various types of integers will try to club together and see what happens in MATLAB. This is also important whenever we try to go for hardware programming. Hardware programming refers to I'm connecting my Raspberry Pi to my MATLAB and I'm trying to write something. Let's assume. So you see MATLAB supports variety of data formats, right? Such as integer 16, unsigned integer 8 bits, integer 32 bits, etc. Right? You see many things are supported in MATLAB, but your hardware may not support all the formats, right? So under such cases we need these conversions, but right now we are not looking at the conversion straight away. We are looking at a scenario when I try to store variety of number representation in a same array. So because array has to have the same type, right, by the definition of array. Let's see that now. Okay, so my intention is now to look at what is going to happen whenever I try to store combining unlike integer types. So this is my side heading. I want to combining unlike integer types. Okay. So always whenever I try to create something like this, right, maybe A is equal to, this is my object. My object is to perform maybe int 16 of a number space, say unsigned integer 8 of a number, and maybe int 32 representation of some number. I'll try to put it in an array. Now you see that this data type A has to be the same. Okay, it cannot change, right? That's the definition of array. You try to collect the values which are of the same data type, then only it is an array. So data type has to be same. It looks like integers, but integer representation is different in this case. Okay, now what happens, right? So MATLAB sets all the elements of the resulting matrix into the data type of the leftmost element in the matrix. First element it's going to check. Alright, then it will convert that into this particular format. Okay, I'll just show you that with an example, but let me write that first. What happens now? We'll see. So the MATLAB sets all the elements of the resulting matrix or array into the data type of leftmost element of that input matrix. Right? In this case, in this particular example, we are expecting all of them to get converted into int 16 itself. Okay, I'll justify that with an example. Okay, so let's move to the MATLAB screen. Let's clear everything, CLC, and now let me create the one which I mentioned. So I'll create a is equal to, so I'll open up the square bracket. Yeah, open up the square bracket, and then I'll first convert the int 16 format. So int 16 of, say, a number 450. Okay, followed by the next number is unsigned integer of maybe 250. Okay, then int 32 of 32-bit representation of say 10000000. All right, this is supported by this. Let's see. Okay, so when I press enter, it's actually converting. Okay, I'm supposed to create an array of this size. Size is 1 cross 3, and I'm expecting a int 16 type of row vector. Okay, just a second, let me just check what I made a mistake. Int 16 just let me enter once again. A is equal to int 16 450, then u int, okay, there is a mistake, this is u int 8 bit size, okay, of 250, and int 32 of 1, 2, 3, 4, 5, 6, 7. Okay, let me reduce one number. Let me check. Okay, now, yeah. Okay, so this is what there is a typing mistake in the previous sentence. Just ignore that. This one you consider. Okay, right? You see, everything is converted into the format. Now, the thing to note here is that I mentioned that. So first two things are no problem. 460, 450 is printed as 450, no issue. Okay. I said 250, that 250 also printed as it is. But you see, when I said into 32 representation of this number, it automatically got converted into this number. Why so? Right? The answer is, what is the maximum, right, 32-bit number you can write? That is 32,767. Using 32-bit representation, when you put all ones, right, 11111, all the 32 bits, right, that number is actually 32,767. You cannot go beyond that. So when my architecture supports only 32-bit, this is the biggest number you can store. So though I said, yeah, I want to store this number, but as soon as I mentioned that I want to use 32-bit representation for this, so that gets automatically truncated to this. I'll show you another example. This becomes more clear to you now. Okay, I will create, say, B is equal to, this is int 8 of, say, 50. Okay, and I will do one more, that is int 16 of, say, 5000. Now, can you guess what happens now? What's expected to happen? So it's let's realize first before we see the result. Okay, so I'm saying use 8 bits to store the number 50. Okay, is it possible to store? I have to check. So what is, using 8-bit numbers, what is the biggest number you can create? That is all ones, 1111, 1111. If you use that in binary, that is 63. Right? So I can write up to 63 using 8 bits. So 50 can be represented. Okay, fine. That's right for us. Then I'll move further. I'm saying use 16 bits to store 5000. So now I have to check what is the biggest number you can store using 16 bits. So I use 16 bits all ones, 1111, 1111, 1111 and 1111. So or 16 ones. So if you use that representation in binary and you convert that into the equivalent decimal, that is 127. Okay, so now using 16-bit representation you can only go with up to 127, right? So that's a problem now. So when I say 127 is my biggest number possible, using 16-bit, it's a bigger number, but you see it converts everything into int 8, right? So using int 8, the biggest number is 127. My mistake, I told that 16 bits are 127. It's not 127. Using 8 bits, the biggest number is 127. So this int 16 gets converted into int 8, and using int 8, biggest number is 127. So I am expecting this number 5000 to be replaced with the highest number possible using 8-bit number, that is 127. Let's check now. So press, so you see it is 50 and 127. Okay, so reason is obvious now. So let's check one more example to wind up with this concept. So I'll create another variable c is equal to, say, this is int 8 of, say, 50. I know this gets printed up as it is, and whatever I enter next to this will also get converted into int 8 format. Okay, so this is uint 8, uint for unsigned int. Okay, unsigned integer. Say the number I want to enter is a negative number, so minus 50. Okay, so I want to print this now. So definitely first number gets printed as 50 by obvious reasons, because it's the first entry. So second one will get converted into int 8. So there is a difference between unsigned integer and signed integer. So unsigned, whenever you say I am trying to represent an unsigned number means it is even the negative number. Negative numbers can also be used to represent using unsigned, but when it comes to integer, it's only positive. Okay, it takes only positive. So minus 50, when it becomes integer, it's the lowest number. Lowest number in integer is 0. Correct? 0 to some 127 you can represent. Using unsigned integer, you can represent minus 64 to plus 63. Okay, total 127 numbers. So unsigned integer 8 of minus 50 is minus 50. But when I want to convert that into int 8, the lowest number in integer will be printed, that is 0. So just check this. So 50 and 0 will be printed. It's because of the same reason. Either you print the lowest or the highest of the out of the truncation. Whenever you truncate like this, this is what is going to happen. Okay, I gave you the examples now. So let us try to move further. Okay, now let us try to combine integer with non-integer data and see what will happen. So next concept is trying to combine integer and non-integer data. So for example, let us assume that I am trying to combine integer with the double, single, logical, right? It will, by default, it will get converted into the data type of the leftmost integer value. Whichever is the leftmost integer, that will be represented. That's the representation of the whole matrix. Okay, so I'll just write. So in this case, all elements of all elements of the resulting matrix get converted to the data type of the leftmost integer. Okay, so this is what's going to happen. I just have to find out where is the leftmost integer. It may not be present in the first position, but wherever you find it, the complete data set of that complete variable, all the set of variables will get converted into the data type of the leftmost one whenever we find it over there. Okay, so let's go to the example. Alright, let me create a variable now. Say a is equal to, I'll use the, even the logical I want to include. It's a mixture now. Okay, it's not a single data type, not just integers. You can mix up real, logical, integers, double, single, etc. So first I'll use true, just to show that, see, true is a logical case. I use a logical data now. Then I use pi. So this is also not an integer. So wherever I find the first integer, everything gets converted into that. Now I will put an integer. So this is int 32 of say that number. Okay, this one. Then use single representation of maybe 17.32 then use a unsigned integer 8 for say 250, maybe. Okay, that's sufficient. Let's see. Okay, my mistake, single. Yeah, see, everything is converted into where you find the first integer, that is int 32. So everything is converted into int 32. You can see here it's a int 32 row vector. That's what I told. Whenever you enter such mixed combination, right, combining integers, non-integers all together in a row vector, MATLAB by default searches for the first type of representation, that is an integer in that array, and converts the complete array into that particular format. Now our intention is to look at the various representation of data in MATLAB. So that is, we can try to implement okay, let's look at the various integer representation formats. For example, hexadecimal, or maybe I want to represent something in binary in MATLAB. So again, this is a very important aspect, very important concept when it comes to the hardware programming, because we know that maybe the microcontrollers, microprocessors, etc., or even the DSP processors, they it's easy to write the code and represent the numbers in binary or hexadecimal when it comes to the hardware, right? So let us see how to represent the binary and hexa. Okay, so if at all you want to represent a hexa number in MATLAB, right? So first I'll go with the hexa. So hexadecimal means you have to start with 0x. 0x, you can write capital, or 0 small x. For example, the number that you are going to enter should be 0x2a, saying that your number is 2a. 2a is a hexadecimal number. Alright, at the same time, let's try to write the binary now, binary data. So you have to start with 0b or 0 capital B. Okay, so the example for the binary number is 0b101010. Like this you can write. Anyway, binary has only zeros or ones present in it, so that's why you are going to write it in this particular fashion. Okay, so binary numbers using 0b, and you will store it over there. Okay, now, so how to convert that back into the decimal number, right? So you can call you can try to represent using unsigned integer format. You can convert uint of that variable, will convert that into decimal. Okay, so obtain decimal equivalent by using the uint8 function, or that particular type conversion can be used for the conversion of the decimal or the binary format into this. Okay, so let's look at the same thing in MATLAB. Okay, so this is so let's start with the the hexadecimal number. All right, so this is 0x followed by, okay, sorry, I missed this is 0x, then now enter the number 2a. So you see, it's actually decimal number 42. Okay, let's go to the other this thing, that is binary. So say b is equal to 0b 101010. So this is also the 42 itself. Okay, so using this we can try to represent them. Okay, so one thing to remember now in MATLAB, by default MATLAB will store a number as the smallest unsigned integer type. Okay, smallest unsigned integer type, whatever is possible, it will store that in the required, in that format. So you can see that, for example, if I write 0x2a, it says that it is uint unsigned integer of size is unsigned integer and the number is 42. Okay, but you can specify that I want unsigned 8-bit, 32-bit, 64-bit, or the unsigned 8-bit, signed 8-bit, etc., or even the signed unsigned can also be used to make the type conversions over here. So I'll show you that now. Before that, let's just write it down. So this is the point. So you can actually specify. You can specify 8, 16, 32, or the 64-bit unsigned types. You have to use the suffixes. One is U8, unsigned 8, then U16, unsigned 16, U32 or U64. Whenever you use this, it converts into the unsigned. Okay, similarly you can use the signed representation. So if you want to go for signed 8, 16, 32 or 64, right, then you are supposed to use suffix. So signed means S. Okay, so S8, S16, S32 and S64 like this. So I'll just show you an example just to make sure that. So we created this. Now I'll say that A is equal to, see, I want to go for 0x, maybe 2a. This is fine, but I don't see by default what is this? This is unsigned integer, right? But I don't want unsigned integer. I want to go with signed 32-bit representation. See, I write S32. That's what I mentioned in the previous page, right? Just check this. So you see, if you want to go for unsigned, use U8, U16, U32, U64. But you want to go with the signed means you should use S8, S16X as a suffix. So just see here, I'm using the signed representation. That's why I'm using the suffix S32. See, it now changed to int 32 format. Right? So it is A is being stored using int 32. You can do this change. This is necessary because of the hardware requirement. Whenever I write something onto hardware, this has to be a specific format. Number is still 32, but it accepts only unsigned, signed, 8-bit, 16-bit, etc. Right? So you have to make a type conversion before you handle the data and you write the data to the input or whatever data that comes from the hardware into your computer. Maybe you are using some sensors such as temperature sensor to interface with the hardware. Hardware reads the data and gives to the computer. it comes in a specified format, you can convert it right as per your requirement. Okay, so that's what we are trying to do. Now, how to convert, right? We can actually perform the conversion, right, between decimal to hexa and decimal to binary. This is the next concept that we are going to look now. So this is the type conversion between binary to decimal, or decimal to binary, and the vice versa. Okay, so let's look at the type conversion. So I'll call this is hex or binary values as text. You can convert this. Okay, this is important because sometimes we might require the conversion, right, into the text format. Right. So we use two particular functions. The first function is DEC to hex. Okay, converts decimal to hex and puts that into the string format. Right. This is, as the name suggests, decimal to hex text format. Similarly, we have the decimal to binary, DEC to binary. So this is decimal to binary text. So now let us look at the application. So let's create the hex. I'll call it as a hex string. Hex string is equal to, directly call a function. Okay, that is DEC decimal to hex of, write the number which you want to write, say 255. So see, it is actually a string form. You can see the double, the single quotes are off, right? So similarly, let's write the binary string is equal to, so DEC to bin of, enter the number, maybe 16 or 15, whatever. See, it is 1111, right? So that's the smallest representation of 15, right? So we can use this technique to convert the decimal into the hexa string, or decimal into the binary string. Okay, moving ahead. So we can actually convert the complete arrays into hexa. All right, so this is a slightly different technique to do this. So let's see how to do this. So this is you can convert arrays of hex values, you can convert that into the text. Okay, so you can use what is called as a compose function, COMPOSE. This is the function to use. Alright, so in this right? Any say decimal array can be converted into its equivalent hexa, and hexa specifically you can write it as a string. Okay, so we have to use one specifier here, right? That is use a format specifier, that is percentage x. So x is hexa, we already have used it, 0x or 0 small x. So now in the same fashion we are going to use this percentage x as the format specifier. Okay, so let's look at an example in the MATLAB window itself. Okay, so I clear and clear the command window. Let's create an array first. So a is equal to, let's create an array, right? So 255, maybe 16, then 12, then maybe 1025, then 138. Okay, I create this. Now you see A is a normal array of size 1 into 5, 1 row 5 columns. Okay, right. Now I use convert this into the hexa. I call it as hex str as my result, the variable holding this result. So use the function compose, compose, right? So this is whatever type specifier you are going to mention over here, or the format specifier you mentioned here, that is used to convert this given A into that format. So for example, I will say use percentage x. This is required for this is required as a format specifier for the hexadecimal point conversion. Okay, then I'll say A. So convert this A and put it as hexa string. So just see, hexa string is equal to 1 into 5 string array. It's a string array now. Alright, so FF 10C 401 and 8A. So you can see that it's getting converted, right, from the decimal array is getting converted into hexadecimal array, and you are going to put it as a string. Okay, right. Now we can convert the binary representation into hexa and hexa to binary as well. Alright, so let's just use those functions to understand how the type conversion happens between binary and hexa directly. Okay. So next is the conversion between binary and hexa. Okay, in order to convert a binary value into hexa, you always start it in the form of binary. You assign it to binary, then use decimal to hexa format. Okay, so first one, that is I want to convert binary to hexa, right? So this is first part. To convert binary into hexa, what you do, so enter the binary value, right, binary value, and convert it into the hexa by, right, decimal to hex function, right? So enter binary and then you can call the decimal to hex. Call decimal to hex. So if you do that, you will be able to convert the given binary into the hexa format. Okay, let's look at that conversion now. So let's create first a variable, say a is equal to, this is 0b, followed by, I'll write maybe 1111. Okay, this is a. Now I don't want the decimal equivalent, because if you simply write a is equal to 0b1111, it will show that 15. I know the answer, right? That is the decimal. I don't want decimal. I want to convert this directly into the equivalent hexa. So what you can do, so b is equal to, right, DEC to hex of this a. Now you see it is f. Okay, like this you can convert. Similarly, now our intention is to look at the conversion of the reverse. That is, I want to look at the hex into binary. So what you want to do, enter the which format, enter the hexa format, then use decimal to binary. Okay, so this is to enter the hex value and then call hex, decimal to binary, my mistake. DEC, decimal to binary function. So it will give you the answer in the binary format. So let's look at the way to perform that. Okay. So let me enter now, say C is equal to, I want to start with the hexadecimal, so 0x, maybe 8f. Okay, now you convert this into the binary. So D is equal to, this is decimal to binary of C. See, that's the answer. So 1000 and 1111. That's the required answer whenever you want to convert the 8f into binary. Okay, now let's move further. Now let's move on to the, after say the numbers, almost everything that is required in terms of numbers representation we try to cover. Okay, so the next thing is we have to move on to the string representation. This is also equally important. Alright, so the next topic that we are going to start is the string arrays. Right, how to create, right? You can create simply by using double quotes. Alright, so first thing is using double quotes, and you can even use another option for this purpose, that is, you can convert the character vector into string by using a function called string function. Okay, you can use string function, right? This can be used to convert the character arrays to strings. Okay. Let's see the examples of both of them. So the first option is directly creation of a string. str is equal to, simply enter inside the double quotes. Okay, so that is hello. Press enter. You can see that that variable has been created, and at the same time in the workspace we can see that you have created a variable called str, and the details can be clicked upon double clicking. It says that it is a 1-into-1 string, right? It's a string of the whole variable. The complete hello world takes only one space, right, of type string. Okay, this is first thing. And second thing is that I want to create a character array. So chr is equal to, let me enter the character array in the single quotes, right? So greetings, my friend. Okay, so now you see it is actually a character array. So you can see that it's actually in the character format. If you double click and open that, it's actually 1-into-20 characters, because there are 20 characters in that, right? So you see previously str was 1-into-1. The whole thing was single location, whereas the character takes 20 locations. Right, so that's the difference between string and characters. Now, how to convert the characters into string? Simply call str2 is equal to, call the function string, string, string of whatever variable it is, chr. Right, now you see the result. This is str2 has been created, but the str2 is 1-into-1. Okay, the whole the complete string is taking one location. So this was the example which I was talking about when we wanted to create the strings. Okay, now actually the strings can also be created using a different technique, that is by performing the by using a square bracket operator. Alright, so let's try to create that. This is to create a string array now. So if you want to create the string array, alright, then use square brackets, right? And what you are going to do here is that multiple strings can be entered inside this, right? So maybe string is equal to this, you can write comma, like you enter a matrix, you can enter semicolon, then something else you can enter, comma, something else you can enter, and close, and do this. So this is how you create, right? Use a square bracket and enter the strings in these locations. So this actually creates what I have shown here is a 2-into-2 string array. Like that I can create many arrays using this. Okay, and I use another function. This is use the function called strlen string length function, right, to find the length of each of the string in that array, to find each length of each string of that array. Length of each string of the array. Right? It actually identifies the number of characters in each of the string. Basically, we are trying to do that. Okay, so let us quickly run that. So, okay, let's create a array. That is, so let's see now how I told I will enter in the same way. Mercury, comma, I'll enter comma, maybe I'll enter third variable as Apollo, right? Then I'll go to the next line and I'll enter then I'll enter maybe I'll enter something like ISS. All right. Okay, so this finishes this. Now you see when I enter, you are creating a 2 cross 3 string array, right? So all of them have been arranged in the form of a matrix because you entered a 2 rows 3 columns type, right? Strings are represented in the same format. Now I use the strlength, that function which I mentioned earlier for this particular A. Okay, so you see it results 766683. So that's what is the number of characters in each of the entries of that array. Correct? So you can use this. This function becomes very handy sometimes. Okay, so that was the string array. So we have an alternative, right? Instead of using string format, you can even use the cell format. Cellular formats can also be used to represent the same. Okay. So this is cell array of characters can also be converted, right, to strings, right? If you write the cell structure, right, for character arrays, you can convert them also into strings. Okay, so this is possible by using which function? Already we have used the function to convert characters into string. The same function we are going to use now, and that function is string function. Okay, we can use that to make this particular conversion. So let's check that. So what I do, I will create okay, this was A, so I'll create B. Okay, so B is equal to, let us create a cell structure. Okay, so to create that, you use a flower bracket like this, and I write Mercury. It's a character array, so you have to use a single quote. Then, okay, then I'll write maybe, okay, 3 different cell entries. Each one is a character array. All right, so I close this. Now you see it is actually 1 into 3 cell array, right? So you can see in the workspace when I open that, you can see that It's 1 into 3 cell. So there are 3 cells. It's a cell array. Each cell contains the characters, right? So now how to convert, right? As we know now, we are supposed to use the string function. So str is equal to, I'm going to call string the string of what's the name? I missed it. Oh, it's b, I guess. Yeah. Okay, simply call string of this. So you see the result str is nothing but, right, it's a string array now, right, of the same thing. Now you can see double quotes over there, which means, right, they are converted into string. Okay, now we have another option here, that is you can actually convert the date and time, the current date and time. So there is a function called, say, d is equal to, the function is called as date time, DATETIME. We will visit the date and time and its representation of various formats later, okay, in a different part of this course. But as of now, let's just remember this one function, which sometimes comes handy whenever you want to read the date and time. And the current date and time can be read using a single command called now, N-O-W, in MATLAB. So you see the D is actually date time format. It actually reads 4th February 2022, 11:56, right, 19. Right, but this is not in the text format, this is not in the string format. This is a specific date time format. This is a new data type supported in MATLAB called date time. Like integer, floating, character, string, you have another variable, another type of data that is called as date time. This is in that format, but I don't want that. I want this to be in the string format. Simply call string. This is the use of string. String of, I think I called it as D. So string of D is equal to, you see. So there is no double quote for this, indicating that this is a date time format. But now the answer is in the string format. You can use it to write it over a text.